So let's check out another problem from Hackerrank. We can abstract this problem into this. So we have a string like that, C, A, B. That's the one from the example. And we have a dictionary of values. So we have got A equal 1, B equal 2, C equal 3, and A equal to 4, D equal to 5, B again equal to 6. Now what we need to do here is to find out the total values, like the sum of all the patterns that are inside. So these are all patterns and we need to find every single fitting pattern inside. So A, as we can see, A right here has occurred here 1, 2, 3. A has occurred twice here and here. B has occurred once. The other B has occurred also once. D has never occurred. C has occurred once. So that's basically what we need to do. We need to fit every single pattern. If it fits anywhere, we need to take it in consideration, and we need to sum every single value when we look up. So if we consider the entire dictionary here, let's try. So we have got C. C is equal to 3. So I'm going to add 3. And then we don't have CA, we don't have CAA, we don't have CAAA or CAAB, so that's fine. Now we move into the next. So we have A, and A has a value of 1. AA has a value of 4. So we need to add up 1 and 4. And now we were standing here. So we're gonna move here. So we have one pattern here, which is A. So we need to add 1. And another pattern here, which is AA. So we need to add 4. And now we are standing here. So we have one pattern here is A. We need to add this A. And we don't have a pattern with AB. Now we stand here. So we check B. B has got a pattern here and here. It has occurred twice because it's duplicated. So we need to add 2 and 6, and that's basically the value of this string. Okay, so let's do the very basic solution that's very slow and ugly. So here it's like this code is already written. So we have we are reading the input. So we have the genes, which is basically the list of strings, which is the patterns that we just saw, and health is another array with the same length, which is basically the values for each pattern. And here we are going through all the inputs. And by the way, so we are going to process several inputs. One more thing we need to consider is that we are not considering all the patterns. We are considering only a range starting from here to here. So here we're not going to consider A. We are only going to consider between B and basically from 1 to 5. So 1, 2, 3, 4, 5. So basically the whole thing except for A. And here we are going to consider from 0 to 4 and so on. And it's giving us here like several strings to process, and what we need is the minimum and maximum. So here the minimum was 0, maximum was 19. Okay, so let's do it. Now I'm processing one string here, so I could process this one and then this and then this. Let's do all the processing. So I'm going to look up every single pattern and see if we have a fit. First, what we need to do is we have our string right here, and first I'm going to stand here, check every single pattern that fits starting from this point, and then add them up, and then stand here and then check if every single pattern could fit anything that's starting from here, and then move on and on and on and so on. Okay, so this means I need to make a loop from 0 to d.length, and inside this we need to pass by every single pattern and do this comparison. So I'm going to do integer j from where to where, I guess from first to last, because we're not considering every single pattern, we're only considering this range. So this from first to last, it's already being parsed here. So j equal first, j less than or equal last, j plus plus, and we need to do the comparisons here. So I'm going to ask if d starts with this pattern. So what I'm going to do is that I'm going to make a substring. So substring, like for example here, if I'm standing here and the pattern is A, I'm going to cut here. For example, I'm going to cut one character, and when I'm comparing against the pattern that's AA, I'm going to cut 2 characters, and this is how I'm going to compare. So I'm going to just like extract a number of letters and compare. So I could say, okay, d dot substring between j, which is where we are standing, and genes of j dot length, genes of j dot length, and then I'm going to check if substring equal to genes j. If so, here I'm going to add the total. So total equals 0, and then we say total plus equal health of j. So we have these two arrays, genes and health, and they have the same size, and each value is corresponding to this value. So that's it. So total in the end would be the value for each string, and now I need to get the minimum and maximum. So I'm going to say, okay, minimum value, maximum value equals 0, and I'm going to say, okay, if the new value is bigger than the maximum value, that I guess I should be the maximum value equal total, and the same for the minimum. If the new total is like less than the minimum, I guess then I should be the minimum. Or we can also do it this way. So minimum value equal the minimum between minimum value and total, and the maximum value is like the maximum between previous maximum and current value, and that's how we get the minimum and maximum. And in the end we have to print these values. So minimum value, maximum value. All right. Of course I cannot start the minimum from 0, because 0 is already the minimum. Like if you are going to pit one value against 0 every single time, 0 is going to win. So I have to raise the initial minimum. So we need to put like something like infinity or the maximum of this type. So I'm going to check numeric limits of integer max. So basically the initial minimum is going to be like very large, almost infinity. So basically the very first value is going to win against this minimum. The same for maximum starts with 0. So the initial value, the first value of the first string we're going to process, is going to win and become the maximum. Okay, so that's it, I guess. Let's try to run the code and see what happens. I think, yeah, we just did a mistake. So here we are supposed to say j, because I think now it became like an infinite loop or something. So just be careful with the variables that we are iterating on. Okay, this should have been I. And we passed the test case. So basically this is the minimum and maximum. So at least we got the concept correctly. Just we have to consider like some of these types. So I'm just like worried we're adding too much values, and I have no idea how how big of a type should we have. So this is like probably maybe 32 bits. Do we really need it to be 32? Do we need it to be maybe bigger? Does it have to be long or something? So I would prefer if this total would be something like unsigned integer 64, and in this case, yeah, minimum value and maximum value as well. This has to be integer 64. We'll check once again, still passing, so that's good. Now, of course, we're going to submit the code. Of course, it's going to be very slow because this is just the basic solution to check if we are actually doing the concept correctly or not. But we are going to optimize and speed up from here. So yeah, we passed 2 test cases. The rest is just saying time limit exceeded, so we are going to need to optimize. Okay. So just like to imagine how many patterns are we comparing against. So we only have like 26. We only have like 26 letters. If we have patterns of 1 letter, it's going to be 26. It could be repeated, so this is like some of them could be duplicated, so that's not our concern. And let's assume just there are no duplications. Let's assume there are no duplications. So 26, and we have other patterns of like 2 letters. So this is 26 times 26, and we have other patterns that are 3 letters. So 26 to the power 3, and it goes on and on and on and so on. So this is not really going to be optimized at all because we are comparing against so many patterns. However, let's imagine that we only have 1 letter patterns. Every pattern is just 1 letter. So if I have only 1 letter patterns, so let's say the patterns are here, and we have 26 of these. This is like 26. And in this case, I have, if I want to compare against 26 patterns, I have to go through them one by one and then check the value and so on. So this is like O of 26, basically. Like we have 26 iterations. However, if these are sorted, then I can just calculate the index and go there right away. So let's say these are sorted. So at index 0 it's always going to be A, at index 1 is going to be B and C and D and so on. So basically, if I wanted to check the value of A, I just need to visit the index number 0. If I want to check the value of E, I just visit index number 4. So I don't need to go through the entire array. I just need to, in one jump, in one calculation, I can just jump and get the value from here. I don't need to go through the 26 letters because I can just, with an index, visit the value directly. So this is for 1-letter characters, for 1-letter patterns. We can just directly, with an index, go to the desired value. So what about if we have 2 letters? In this case, we could do something like this. So with 1 letter, I could just go directly to the location I want. With 2 letters, I would take the first letter, go here, and then each letter would have its own array. So basically, A would have a hidden array that it has. So it will have another array consisting of like 26 items, and we can use this for looking up the second letter. After we look up the first letter, we check, okay, we landed here. Now we look up the second letter and we get the address of this array from here. And then C, of course, would have another one. So every single time we have a pattern that has got a next letter, it will have its own array, and then each of these might also have a next character, so it will have also its own array and so on. Basically, this structure is a tree. So what we have here is something like this. Let's say we have patterns like that, so A and then AB, and then BA, and then BD, and then DE, and so on, and then maybe DEC. So basically we have one tree like this. So A would have its own value. Let's give them some values. So this is 1, 2, 3, 6, 7, 11. A would have a value of 1, and then A would also lead to B, and then B would have a value of 2, and then we have another tree starting from B, and then B would also does not have its own value, but it could lead to A, which has the value 3, and it could also lead to D, which has the value 6, and D is also another tree. It has the value, it doesn't have a value of its own, but it could lead to E, which has the value of 7, and E could lead to C, which has the value of 11. So basically we can just compare our string and process this tree one by one. So if we have a string that says like AB something, we just go straight to A. We add this one, we go straight to B. We don't need to visit any of the other items, because we can just look up every single character and then go to the next and the next and so on. So this way we are saving on lookup time. So instead of going through the entire dictionary of patterns, we just look up in just one jump, just by calculating the index, just by jumping from one pointer to the other. So let's try this approach. Okay, so here we have a node in the tree, and then this node would consist of okay, let's say it has a value. So the node has a value, and it could lead us to the next node. So basically we have an array of nodes. Let's call them like next, and they are only 26. And these could be like private or something. And then we have let's add some public functions. So basically the constructor, when we construct a new node, in this case we need to initialize all of these with null pointers. So for nigger I equals 0, I less than 26, I plus plus, and then next of I equal null pointer. And we need to add other functions. So let's say I want to ask if you have a certain character here. So if I want to check if you have this child, so I would say has child, or has next. So I'm going to return next, of course. Okay, first this is a character, and it's not from 0 to 26. So we need to say C minus equal A as a character. So here, if it's A, it's going to be 0. If it's B, it's going to be 1, and so on. And then I'm going to return next not equal to null pointer. And if I want to jump to the next, if I need a pointer to the next node, let's call this jump. Jumping to a character, I'm going to return, of course, C minus equal A, and return next of C, like that. Okay, so this is like the node. It's a very basic design, and let's get the value, for example. So we can just ask for the value, calculate the value, so it should return the value. Now let's do another class for a tree. The tree would have, I guess, a root. So root, and let's initialize this root in the constructor. So I guess this root is just a normal node. So what do we need to do with the tree? For example, we are going to add one item to the dictionary. So in the beginning we'll keep adding these items. So we have A, we have B, C, A, and so on. So we have a function called add item. This function would take a string. The string is a pattern, and it would take a value. I guess also we need to set values, so I'm going to make another one, set value So how do we add a value? So first we need to check if root has the first character or not. So I would have to ask if root has pattern of 0. So what if it does? What if root has the first letter? I mean, what if it doesn't? First, what if it doesn't? Then I guess we need to add a new child. So I think here we need to add another function that says, add, add child, or make child. And in this case, we are gonna say C minus equal A, and then next of C equal new node, and that's how we have a child. And of course, maybe you need a pointer to this child, so I'm going to have to return it. So what if we want to just get the pointer like this? I don't want to check in the outside class. I want to do the check here. So make child would create if it doesn't exist, or would just return it if it already exists. So I could do something like this. So I'm going to say if next.c equal null pointer, then we create, otherwise we just return. This is make child, or go through, maybe pave, I don't know, we can just give it a name, but in the end the function would just like create it if it doesn't exist, or return it if it already exists. So instead of this, I'm going to say pointer equal root, pointer equal root dot pave pattern of 0, and then after we arrive at 0, I guess we need to go to the next one. So it's mostly like this. So if I have here A, and the pattern I'm entering is like A, B, C, so I need to go to this to pave the way to B, and then pave the way to C. After I finally arrive at C, I give C the value. So the value would just go to C, but at least I need A and B and C to exist first. So depending on how much or how long the pattern is, I need to make the tree, and then the final item I need to give the value to. Okay, so we're going to do it this way. So for auto C in pattern, so for every single character in this pattern, basically I'm going to I create the child if it doesn't exist, or return it if it does, and keep going until I finally arrive. So after we finish, this pointer would just carry the pointer to C like that. Okay, so in the end, pointer dot set the value to value. This is how you set a value. Okay, so what if we just need to calculate a value? So this is the add. So the add would be calling it from here. So as we can see, we're going through the health items one by one. So these are the numbers that correspond to the patterns. And I'm just going to say, okay, let's create our tree. So tree. And basically we say tree.add pattern. The pattern name is genes of I, and the value is apparently health item, and that's it. So I'm in the beginning I will just add every single value, and then here we need to read these values. We need to get the value of a certain string. Okay, so let's say get value or calculate. We have a string as an input, so this is our input, and maybe we want to start from a certain index. So basically here we are going through the string character by character, and sometimes we start from C and then start from A and then from A. So we need to keep track of this index. So here we are starting from this index, we are processing this string, and that's it. So we need to go through the entire tree and calculate these values. So I'm also going to do this. So I could just go through the whole tree, but I'm not going through the string from the beginning. I will just start from index and I less than input dot length I plus plus, and then I would say C equal input of I, and this time I need to return to get these values. So actually a value should have an initial value which should be 0. I'm going to say something like total plus equal pointer dot calculate, and in the end return this total. Alright, so now instead of going through every single item in this dictionary, I'm going to do it this way. So I'm going to say total plus equal 3 dot calculate my string, which is D, starting from the index I, and that's how I get the total. So let's run the code and see what happens. And we got the wrong answer because apparently this string was evaluated at 23, not 19, because we shouldn't consider we shouldn't consider A. We should only consider patterns between first and last, which we did not do in the tree. So this means every value, so let's do it right this time. So every value could be duplicated, so we could have B twice or multiple times. So it's not just one value, it's a list of values. So we need to do a vector of values like that. Not only that, but every value has an index. It could be within our range or not. So this could not be in our range. So we only consider all the values between 1 and 5 or between 0 and 4 and so on. So we need to remember the index of this value, like the index in the dictionary. So I'm going to create a tuple between an integer and integer 32, and these are all our values. When we calculate, we need to return this thing. So I'm just going to write O2 and we return values. I guess we can call it values. And when we set a value, we need to remember the index. So basically values dot pushback make tuple index and v. When we calculate, we need to add up all these values. So let's do it this way. So for auto item in total equal, so this item is a tuple of a value and an index. So I'm going to say auto we have the index comes first, I guess. So index and value equal item. So I'm just breaking the tuple, so index and value, and I'm going to add the value. Of course, this value has to be within the range, so I need to ask for the range. So the range would be like, we have first, we have last. I need to, before adding, I need to ask if it's within our range or not. So if index greater than or equal to the first and index less than or equal to the last, and that's the only time when I add the value. And now since we are already like changed some of these interfaces, we need to adapt. So when we say set, where do we call set? Set was called here. So in add, we need to add the index and pass this index. Where was add called? Add was called in this instance, so we're gonna pass I, that's the index. And when we calculate, we need to give our range, so this is first and last. Okay, so let's run our code and see what would happen. And we passed the simple test case. Let's submit and check the rest. Okay, and we see in some test cases we are failing, so this is abort, abort, abort. I guess there is like some memory violation, I guess. Let's find out why. I think we are also like I think I know what happened. So basically we are going through the entire string, and we are always trusting this pointer and never really checking if it's null or not. So basically, if we are in this tree, so we went to A and then we asked for B, we checked B and then we asked for C, we checked C, and then there's nothing else, like, but we still kept going, and we trusted that it returned something, but it didn't return anything. So first, this is okay. This is sorry. This is when we calculate. We need to say jump. We don't need to allocate anything. And before we jump, we have to ask if it has next or not. Has child C. If it has the child C, we do this. If it doesn't, we just abort, or we just break. If it doesn't, then we just break. Let's check the simple test case, and it's passing. Let's submit the code, and everything is passing. So that's how you solve this problem. So thanks a lot for watching, and see you in the next problem.